Making this video to give a couple of clues about this modeling task. We are looking at the total number of views in terms of days of Despacito, which, according to Billboard, this video broke several streaming records in 2017. And the slideshow has an excerpt from an article that actually gives us some data. So here in the words section, I just summarized really at a high level what the article says. And then I was able to pull these 3 data points from the article, and I collected those here in this data table. And now the challenge is to try to use this data to develop an equation. First thing I'm going to do is I'm going to define my variables. And of course, we can just use x and y like normal, but if you notice, we have our independent variable is the days, and the number of views depends on how many days have passed. So for me, the independent variable is the day, and I'll use the letter D to represent that. And the dependent variable is the views of this video, which is, I'm going to use the letter V. So the next task is to write an equation. And the first thing I want to think about is what is the nature of a viral video? I will find a video online and I'll get so excited about it, maybe I'll post it on all my social media outlets and I will share it with all my friends, and then 10 of my friends will watch that video. And then they'll get so excited about it, they'll post on their social media sites, and 10 of each of their friends, so 100 people will then watch the video, and then 1,000, and then 10,000. That's the nature of how things go viral, videos or whatever. And so that follows an exponential pattern. And so I'm just going to assume that this is going to follow an exponential pattern. And of course, I have this blue frame on which we summarized all of the information that we're collecting about exponential functions. And I just want to draw your attention to this piece right here. This is the equation, the general form of the equation of an exponential function. So I'm going to start with that equation. Now, I don't know what the initial value is, and I don't know what the multiplier is, but I do have my variables. So I'll use these variables to write first the function v, the number of views depends on d. V of d is equal to a times b to the power of d. And that's my equation. And I don't know what a and b are yet. I know some people have suggested that, well, the initial value has got to be 0, because the moment that they posted this video, nobody had actually viewed it. And that is true. But imagine in this equation, if we set a equal to 0, then we would end up with this entire thing being 0. The multiplier wouldn't matter. Whatever day it was wouldn't matter. The number of views would just always equal 0, 0, 0. So while the reality and through reason, we understand that there are actually 0 views at day 0, the moment that this video is launched. But that doesn't help us model the situation. So I'm not going to assume that the number of views was 0 at day 0. Instead, I have to figure that out. And so I have 2 unknowns in my equation, a and b. So I'm going to use these data points over here in order to create 2 new little equations that I can solve for a and b. Let me do it this way. I know that from the article that V of 1, the number of views after 1 day, is equal to 5.4 million, and I'm going to leave off the million, I'm going to write my equation in terms of millions of views. Maybe I should write that up here. The dependent variable is not just views, it's millions of views. V, there we go. 5.4 is how many millions of views there were after 1 day. So this is A times B to the first power. And I can just simplify this a little bit by writing 5.4 equals A times B. So there's one equation, and it's a pretty simple equation, and it has two unknowns, A and B. I can do the same thing over here with 22 days. I know from the article that after 22 days there were 200 million views, and so that should equal A times B to the power of 22. So I've taken some data points from the article, and I've just applied them to this general exponential equation. And I get this, and then if I simplify the other equation, I get 200 equals A times B to the 22nd power. And so now I have two equations and two unknowns. They are not linear equations, so the solution can be a little bit tricky, but I hope that maybe you would pause the video right now and try to solve these two equations for these two unknowns, A and B. And then you could rewrite this thing with the A and the B that you find, and you would have your equation that models this data. If you're a little bit unsure about how to get started, consider this first equation. I'm going to solve it for A by dividing both sides by B. Here my B's cancel, and I get 5.4 over B is equal to A. And I can use substitution now to substitute this into my other equation for the A, and I will effectively eliminate A from this equation. Let's see what that looks like. 200 equals 5.4 divided by B times B to the 22nd power. So now I have one equation with one unknown. And let's do a little bit of reasoning about this to simplify the right-hand side. Consider B to the 22nd power. What does that really mean? It means B times B times B times B times B 22 times, and then I'm going to divide out one of those B's. So really, B to the 22nd power divided by B is just B to the 21st power. So 200 equals 5.4 times B to the 21st power. And now you can just solve this equation for B. It's a little bit tricky, but let me just walk you through a couple of things here. First of all, immediately some people see that, oh, let's divide both sides by 5.4. And you can do that. You get 200 divided by 5.4 equals B to the 21st power. And so how do you undo B to the 21st power? Remember, if this was just a B squared over here, then I could take the square root of both sides of this equation, and that would give me B. But here it's B to the 21st power, so what you need to do is take the 21st root of this quotient. There is a button on your calculator somewhere. Of course, there's a button to take the square root. We've been using that. But you want to look for a button that has the xth root, like this. There's some function on your calculator to take the xth root. And I'm not going to do any more of this problem here on this video, but I want you to figure out what B is by solving this equation. Make sure you make some good rounding decisions when you get it, because you will get a decimal number. And then take your B, plug it in right over